Like any automatic transmission, the condition and level of the fluid inside a CVT unit will determine the performance. CVT transmission fluids are different than automatic transmission fluids for 3 reasons. The color of the fluid for some CVTs is either green or yellow. The fluid can darken over time as it is oxidized. One reason why this fluid is different, it's got to protect against wear to the chain or belt. Second, the fluid has to have high shear stability due to the high pressure requirements to operate the pump and variators. Third, the fluid must protect the friction materials of the forward and reverse clutches, along with the start clutch if it's equipped that way. Due to different CVT transmission designs, there are many different formulations of fluid. Temperature is another unique requirement of CVT transmission fluid. The fluid should be up to temperature for the variators and clutches to work as intended. Many CVT transmissions use a warmer that uses engine coolant to get the transmission fluid up to temperature faster. The warmer can also be used as a cooler when the fluid is lubricating and cooling the internal components. Some CVT systems can also have a complex system of thermostats to keep the fluid at the correct temperature. For example, you could be dealing with a warmer and cooler on the transmission, and then behind the radiator or in front of the radiator, another cooler. As to the condition of the fluid, you might be alarmed when you pull the pan on some CVT transmissions and you look at the magnet and even the pickup screens. You might see a lot of metal debris during the first fluid change. This is normal for CVT transmissions. The metal is from the chain or belt, and the path of the fluid is designed so the debris is captured by the magnets and the filter in the pan, and they don't circulate through the transmission over and over. Some transmissions also use an inline filter that looks like an oil filter. The fluid level is critical for a CVT transmission. If there is too little fluid, the transmission will not shift properly, and the air can enter the valve body and then the variators. An overfilled CVT transmission can cause the fluid to aerate and get in contact with the moving parts. The air can change how the pulley and solenoids operate the plates. This can cause slipping and incorrect ratio codes. Also, the lack of lubrication can damage the belt or chain. Setting the fluid level is critical after a fluid or filter service or any repair where fluid is lost. To check and set the fluid level, you will definitely need a scan tool and maybe a dipstick that is designed as a service tool. Any transmission fluid will increase in volume as it's heated. Many CVT transmission fluid manufacturers have a recommended temperature range to check and set the level. This temperature needs to be checked using a sensor mounted in the valve body. Guessing the temperature or using an infrared thermometer, it's not an option. The other reason for a specific temperature is the cooler and the transmission. Most coolers are controlled by a thermostat, and it will not circulate fluid until a specific temperature is reached. Some CVT transmissions, well, they're going to have a dipstick. Others will require a special dipstick tool that can be inserted into a port. But some CVT transmissions will use an overflow tube in the pan to set the final level. Not following the recommended procedures can lead to an under or overfilled CVT transmission. Often the mistake is realized when the driver leaves the shop and the fluid reaches the correct temperature. The symptoms could be poor shift quality or even noise. This is because air is trapped inside the cooler circuit and then it's circulating through the transmission once it warms up. Next, let's talk about line pressures. Due to higher pressures inside a CVT transmission, you are going to need a new pressure gauge that is rated for at least 1000 psi or higher. What can a pressure reading tell you? Well, a lot. A typical CVT transmission will have pressure ports after the pump, variators, and the forward and reverse clutches. In addition, some CVTs will have ports for the torque converter and even the lockup or the start clutch. So what can you test with the pressure readings? Well, just like an automatic transmission, pressure readings can confirm mechanical operation of the actuators and the accuracy of the pressure sensors, and if there is any internal leaks. In the service information, you can find specifications for the pressure readings for the different hydraulic circuits you are looking at. And also you'll find hold and release pressures for a given circuit. In the case of variators, the pressure can vary with the commanded ratio by the TCM. Even if you have the readings of the line pressures, you still need to verify the electronic operation of the solenoids.